Okay, did you understand how to do it?
Yes.
This is very simple. All the light rays which are incoming parallel to the principal axis, they are all deflected towards the focal point. Okay, so you just need to draw lines for all these rays going through the focal point.
And how did you find where the focal point is?
It said the focal distance is the distance between the lens and the focal point. This is the focal distance. Okay, so it says 50 millimeters. I just measured 50 millimeters and the focal point is there. Okay? And so all these light rays, they all converge on the focal point, which is at the focal distance from the lens. Okay? Okay. Now we have in the second exercise something different, which I didn't explain you yet how to do it. We have a light ray which is not parallel to the principal axis. Okay, so this light ray is not going to go through the focal point. Okay, it's going to go somewhere else. And how do we do that? So please make a note, or you want me to write it on a separate page? Let me write it on a separate page, and this you can make a note of it because it is not explained in details in the course. Let me just check, because for some stupid reason I don't have the same course in French and in English. No, okay, it's not said. Okay, so light ray which is not parallel to the principal axis. Okay? How do we deal with that? So let me do a drawing. We have a principal axis. We have a convergent lens. And we have a light beam that arrives, let's take just, I don't know, this direction. Okay? Where is it going to go? Let's assume the focal point is at 1, 2, 3, 4, 5 centimeters. Let's assume the focal point is here. Okay? If I had a light beam which arrives parallel to the principal axis, it would go here. If my light beam arrives more like this, then probably it's going to go lower, but we don't know exactly where. Okay? How do we do that? The rule is the following. You draw a parallel to the light beam passing through the optical center. The optical center is the center of the lens. Okay? You draw a parallel to that light beam through the center. Okay? And then here you will draw something that we call the focal plane, because actually all this happens in 3 dimensions. Okay, we do drawings in 2 dimensions, but all this is in 3 dimensions. So this is the focal plane. It's a plane which is perpendicular to the principal axis at the point where we have the focal point. Okay. Well, the intersection of the parallel to the incoming light beam and the focal plane gives you the direction in which the light beam is deflected. So this light beam is going to go like this. Okay? You understand?
Yes.
Yes.
Okay. So now try to do exercise number 2 by yourselves. It's exactly the same situation, and then we will take it from there. Tell me when you are done and when I can correct. The correction? Or you want some more time?
Yes.
Yes, what?
Correction.
Okay. So we draw a parallel to the incoming light beam. Okay. And just one comment, when you do a test about that, I don't know if we will do written tests or oral tests, but when you do a test, draw these construction lines, okay? They are important. If I see just the result without the construction lines, I will not be happy. So this is the parallel to the incoming light beam. This is now the focal plane, okay? We have the intersection here, and so this light beam is going to be deflected through this point, this intersection, and it's going to go like this. Okay.
Why are there two focal points?
Sorry?
Why are there two focal points?
I didn't introduce that because normally, you know, a lens is a symmetric object. If you take a lens which has the same curvature on the two sides, it's symmetrical. So we tend to put one focal point on each side. They are at the same distance. And this focal point here is called the image focal point because this is where the image is forming. And this focal point here is called the object focal point. And for a divergent lens, it's inverted. The image focal point is on the left and the object focal point is on the right. Okay? So we always have two focal points for a lens, one on each side, because lenses work in a symmetric way. Okay, try to do the next one. It's basically the same thing you need to do. You need to draw a parallel, and then you need to construct the focal plane, etc., etc. you done?
Yes.
Yes.
Okay, so it's the same as before. If I find my, we need to draw a parallel to the incoming light ray. Then we need to draw the image plane, and then we have this intersection here, which tells us that this light beam will go that way. Okay? You see, if we had a light beam which arrives parallel to the optical axis, to the principal axis, it would go down this way. Okay, so it's quite natural that if this light ray arrives a bit like this one is going to go a bit up like this. Okay, you see?
Yes.
Okay.
Yes.
Now try to do the next one, and the next one is a bit more complicated because it's full of lines. Okay, so you need to decide for every light ray where it goes. Maybe I suggest this exercise we do it together, because if you do it alone and I correct, there will be lines everywhere and you may have difficulties understanding. Okay, so I would prefer that we do it together, this one specifically. Okay? Okay, all the light beams arrive with the same angle with respect to the principal axis. Okay, so if we draw a parallel, this parallel will be the same for all the incoming light rays. Okay, and this parallel is here. Right? And now we must construct our image plane, which is here, and it gives us a point here. And this point that we constructed here is the same for all the incoming light beams because they all have the same direction. Okay, and so they will all end up here. Okay, so the first one, you know, if there was only this light ray, we would have done this construction and it would have gone like this. Okay, the second one, it's the same construction, it would have gone like this. The third one, it's the same construction, it would have gone like this. Now this one passes through the center, so it's not deflected. We will see that in a moment. And then the next one is going to come here, the next one is going to come here, the next one is going to come here. Okay? So you see that all the incoming parallel light rays, they meet in one point, but this point is not on the principal axis, it's away from the principal axis on the image plane. Okay?
Yes.
Good.
Yes.
Let's now go to the next one. Oh God, there is something, there is a sentence missing. Let me see in the other course. It says, draw the light beam after the lens and the focal distance is minus 50 millimeters. Why minus 50? What kind of lens is that? Look at the drawing.
Divergent?
It's a divergent lens, okay? And as I told you, for the divergent lens, the image focal point is on the left. I mean, we have the convention of drawing it on the left. we have the convention that light beams arrive from the lens. So here the focal point is here. Minus 50 indicates you the fact that it's on the left for a divergent lens. Okay, so you remember how we did that for a divergent lens? This light beam is going to diverge, so we expect that it's going to give us something like this, right? And so this beam here is going to go where? This beam here is going to go in a direction given by a line which passes through the focal point and is going to go like this. Okay? This here is going to follow a direction which is given by the focal point. So again, we do this construction. And it's going to go like this. Okay, and please, when you draw these things, make a difference between solid lines which represent light traveling and dashed line which represent construction lines. Okay, because here there is no light passing here. Okay, then the next one, it's going to go away again from that direction. Okay, this one is going to go straight. It's a general rule that the light rays which pass through the center of a lens, they are not deviated. We will see that in a moment. Okay, and then this light beam here is going to go in that direction. Oops, sorry, I had a weakness. And this light beam here is going to go in that direction, and finally the light beam up there, it's going to go like this. Okay, sorry for this here, my hand slipped. Okay, as you can erase. Oops. Okay, next one. I will let you do that. This is a bit more complicated now, because you see in the exercise that we had before, we had many light rays arriving, but they all had the same direction, the same angle with respect to the optical axis. So we could use the same construction for all of them. Now in this exercise we have light beams which arrive in different directions. So for each one of them we need to do the construction that we did before. Okay, let's do the first one together. Okay, and I would like to check one thing. This is where, okay, the focal point, you see it's not very clear. It's here at 2 centimeters, so on the other side it's also at 2 centimeters, and it's here. Okay, it's not very clear. Well, anyhow, we will not use this focal point, but I just wanted to make this clear. Okay, let's start with this one up here. Okay, what do we do in order to know where it's going? We draw a parallel to this light beam passing through the optical center. Okay, and then we compute the intersection between this line and the focal plane. Okay, so here we have the intersection. Okay, and so this light beam here is deflected in that direction. Okay, Now I'll let you continue for the other ones, or you want us to do it together, as you like. Continue with the other ones.
Fine, we can do it.
Yeah, do it, and I will correct in a moment. Can I do it? Are you there?
Yes.
Yes.
Okay. Okay, so let's do the second.
Find, the point.
How do we find what?
We do with the point on the focal.
How do you find it? Well, it's given.
Yes.
It's given. I
Yes,
don't.
but, how do we find like where it's gonna, like the point you found?
Which one? This one?
Yeah.
This one is the
Yes.
intersection between the focal plane, which is here, and a parallel to the light beam, which is incoming.
Okay, that's the same thing as before.
Yeah, it's the same, it's the same. But now we have different light rays arriving in different directions, so we need to do this construction for every light beam. Okay, you see, for the second light beam, we need to draw a parallel to this guy through the optical center, and this parallel meets the focal plane here, and so this second light ray, it will be deflected towards that point. So it's going to do this. Okay? Then the very interesting thing, I will do it in green, this one, is this ray here, which is parallel to the principal axis. Do you remember what we said before? A light ray which is parallel to the optical axis, it goes in which direction after the lens? It goes through the focal point, okay? And indeed, if I draw a parallel to that ray, it's going to be here. It's going to be on the principal axis, okay? And it will define this point. And now we see that the light ray, it's going to go this way, okay? So this we could have drawn even without doing all this construction. Okay? The next one is also an important one because it passes through the center, so it's going to go straight. You want to demonstrate that? Yes, you can. Okay? It's very simple. You draw a parallel to this light beam. It's going to be just the line on which I am. So it defines this point as an intersection between the optical plane and the parallel, and this is exactly in the path of the light ray, it indicates that the light ray is going straight. Okay? Then for this one, let's draw a parallel to it through the center of the lens. It defines one point here, so this guy is going to go like this. You see that here the light rays, they don't meet in one point. If you want to do an image with that, the image will be blurred because the light rays, they don't meet in the same place. And here, what do? Well, we can do the construction, draw a line, okay, and so this light ray is going to go like this. And what do you observe? Do you observe something peculiar about this light ray, the last one I drew? This one, sorry? It's parallel to the principal axis, and this is actually related to the fact that it comes from the focal point. Okay, we will see that in a moment. If a light ray comes from the focal point, it will be deflected parallel to the principal axis, and conversely, if it comes parallel to the principal axis, it's going to be deflected towards the focal point. So this is also one of these peculiar rays. And then we have this one. So for this one, there is nothing special we can do. It's not a special case. So we just draw our line, we extend a bit the focal plane, and this light ray is going to go away in that direction. Okay? So you see that the object which is here gives us an image which is here, but the image, the points, they don't fall all on the same point. If you have an image here, it's going to be a blurred image. Okay? And this one is a bit the same. You want to do it? Or, yeah, let's do it. It's again the same technique. We have to draw the focal plane, and then we draw parallels for these beams. So here we draw a parallel for the first beam. It's going to get up here. Okay, the point is here. And so this light here, this light ray is going to go this way. You see, this is a convergent lens, okay, but the power of this lens apparently is not enough to make this light ray go down again. It decreases its divergence, but it doesn't make it go down completely. And then we have this one, so we draw a parallel. This defines a point, and so this light beam goes through that point. Okay? Then we have this one. We draw a parallel. So this one is going this way. Okay. What about this one? Do you know where it's going?
To the focal point.
To the focal point, because it arrives parallel to the principal axis. Okay. What about this one? Do we know where it goes without anything? Without doing strange things? Okay,
Go straight.
it goes straight because it passes through the center. Then this one, now we need to start drawing parallels again. So let's draw the parallel here. Okay, this is going to go like this. Okay, and this one here, well, it's and the last one, I'm not even sure I can do it on this drawing. Okay, so this one is going to go that way. And this one here, I don't know if it will enter the drawing. Yes, well. Yeah, this one here is going to go in the direction of the intersection down there. Okay? So you see, it's a convergent lens. We had light rays which were very divergent, and here they have become less divergent. The lens had made them converge a bit more. They're not converging on one point, but they are less divergent than before. Okay. The fact that here we could have all these light beams meet in a certain area here is related to the fact that the source of light is at a distance which is larger than the focal distance, whereas here the source is at a distance which is closer than the focal distance. So this makes a big difference for the lens. Okay, it's just a comment, don't worry for the moment. Okay? Okay, now I have another thing to tell you before I give you an exercise for next week, is how to form images. Okay, so let me see if I take the course. Okay, let's take the course on page 30. I cannot read. It's what? 37 maybe. Okay, this page, imaging properties. So when you want to construct an image, you need to have every point of the object giving you one point on the image. So this is here an object. Let's imagine this is a person. Okay? And if I want to have an image of this person here, I need every point of that person to give me one point on the image. Okay? And in order to determine where this point is, we are going to use specific light rays. Okay? And we have three types of specific light rays. We have type 1, type 2, and type 3. Type 1 is a light ray which is parallel to the principal axis. It arrives parallel to the principal axis. It ends up through the focal point. The focal point is here. You have the focal distance here. The focal point is here. Okay, and the other focal point is here. Okay, so if it's parallel to the principal axis, it goes to the focal point. Right? I will maybe do these three beams in different colors because this is important. Okay, so first thing is this. Okay. Then the second one, let me do it in brown. The second one, we met it before. I made comments about that. This is the light ray which passes through the center. Okay. And so number 2, if you pass through the center, you are not deflected. Okay? The light beam which passes through the center goes straight. And then the situation 3 is the same as situation 1 in some sense. Okay, it's just the direction of the light which changes. Here you arrive parallel to the principal axis, you end up through the focal point. Here you pass through the focal point and you end up parallel. Okay, so it's basically the same thing, except with light that goes in the opposite direction, but it's the same phenomenon. It's related to the definition of the focal point. And so if you arrive on the lens coming from the focal point, you will be deflected parallel to the principal axis. So 3 from focal point means parallel to the principal axis. And these 3 remarkable light rays, remarkable in the sense that they are specific with respect to the others, these 3 remarkable light beams, they allow us to construct images. I give you one example for constructing an image. Okay, then after that we will stop. Image construction. So let us have a principal axis. Let us have some lens, which is here. Let us have some focal distances. Okay, let's say 4 centimeters and 4 centimeters. So here I have F, here I have F prime, and I have some object here. What object do you want? I don't know. Let's take a Christmas tree. Okay. And we want to know what is the image of this Christmas tree through this lens. In other words, if I have this tree here, I put a lens and I put a screen here, where do I need to put my screen in order to see the image of this tree sharp? This is the real question. Okay? So what do? I take 1 point on this object. Okay, knowing that the image is made up of an infinity of points, but we need to work with 1 point to start with, and for this 1 point I construct my remarkable rays. And the remarkable rays are what? There is one which goes parallel to the principal axis, and then it goes where? Through F. Okay. Another remarkable light beam is the one that passes through the center of the lens, and we said this one is going straight. Okay, so now I realize that this one is not long enough, so I will make it a bit longer, and you see that these 2 rays, they meet here, meaning that this point at the top of the tree has an image here. It's an inverted image, it's down, it's inverted, and the image is also a bit bigger than the initial object. Okay, and we will see later the laws of lenses, all that is related. Okay, and this will be the image of the top of the tree. Now, sorry, and one thing I didn't tell you, but I should, is that we have a third light beam. Okay, the third one, a third remarkable light beam. So let me try to do the drawing not too wrong. This is the light beam which passes through the focal point. Where is it going after the lens? If it passes through the focal point,
It's going straight.
it's going, well, straight is not a really clear word in physics and geometry. Okay, try to use parallel, or because straight doesn't mean much. You see that all these three beams, they meet in the same point. You don't need three, you can work with two. Okay, but if you want to be sure, you can use the three of them. Okay, so this point here as an image here. Now let's say this point here in the middle of the tree is going to have an image where? Well, let's draw one ray which is parallel to the principal axis. It's going to go in which direction? Through the focal point. Okay, so it's going to go somewhere there. And then we have a second remarkable light ray which is going through the center of the lens, and it's here. Okay, and you see that these 2 points, they meet here. These two rays, sorry, they meet here. So the image of the tree in the end is going to be down here. It's going to be a bit bigger. Okay, and it's going to be inverted. This is what we call a real image. A real image, and it is inverted because it is turned, it has head down, whereas this one is head up. Okay, a real image is what? Is an image that you can project on a screen. So here there is light arriving, you can project this image on the screen. If you put a screen here, it's going to be lit, there's light arriving, and you are going to see your tree there. With divergent lenses, we will see this later, we have virtual images. So these are images that you see, but there is no light arriving there. We will discuss that next time. You had a question? Somebody had a question?
What is the light point?
Sorry?
The light point. What does it define?
Which point?
The red one. The last image.
This one?
Yes.
This is the image of this point here.
Oh, this one. Okay.
Yeah, and you know, if I want to construct the image of my tree, the tree is made of an infinity of points, and I need to compute the image of this infinity of points to construct the image. I'm doing only a few, okay? But in principle, an image is a set of points, and each point, if you want it to be focused, you need to have the light beams meet at a certain point. So if you put your screen here, all the points in the image, they will be sharp. If you put your screen here, the points on the image will not be sharp, the image will be blurred. Okay? Okay.
Did you say that
Sorry?
Did you say that the image is bigger than the original one?
Yeah, you see it here. Okay?
It's bigger.
It's bigger. We will see next week or later the basic laws of lenses, and these laws, they relate the distance between the object, the distance to the image, the height of the object, the height of the image, etc., etc. All this is connected. Okay, but I'm not going to go into that one. We will into that now. We will see that later. What I would like you to do for next week is a very simple exercise so that you have something to do. I would like you to do this exercise here. Okay, this I would like you to do for next week. You have an object. The object is AB. The object goes from point A to point B, and we want to find the image A prime, B prime of the object AB. And you will see different situations in which AB is far from the lens, closer to the lens, closer to the lens, and then also where the object AB is at the focal point. You will see what difference it makes. So just draw these different cases according to the
I just
rules
have a
we set
question.
today. Yeah.
For the first example on exercise 8, A is going to be on the axis in the image.
Okay, A, if you want to draw your remarkable rays, you see the ray which is leaving from A going to the lens passes through the center, so this point is going to be on the line, on the principal axis. And if an image is vertical, if an object is vertical, the image is also going to be vertical. So actually I can do this one with you now. Okay, for this one, what would you do? Well, you would construct just the image of point B, because the image of point A is going to be just below it. So you can construct the image of point B by going, here it's parallel, so we are going through the focal point. Okay, and this one, and there is one which is going like this. Okay, so we are going to have a very small image here for this case. My drawing is not very precise, but basically it's going to be that. We are going to have a very small image here. For this one, we are going to have an image which is a bit bigger, etc., etc. Okay? Try to do the exercise and we will discuss it next week.
Okay.
How is it with these classes online? You think it's better, it's less good, or what is your feeling? Hmm?
It's okay.
It's okay.
Yes.
Doesn't mean much, it's okay. But
They're the same.
okay. Okay, so have a good evening. I will put, no, actually the recording stopped. Listen, the recording stopped when I had all these problems. No, now it's recording. I will put online whatever I have, whatever has been recorded. I will send you an email. Okay?
Okay.
Okay. So thank you for being here and for being so nice, and have a good evening and take care of yourselves.
Thank you.
Okay.
Thank you.
Bye bye.